Hello, Math 45 students. Let's go over the homework in Newton. So I believe it was 5.1D, and the topic was applications of quadratic functions here. So here we want to determine the maximum and minimum values of the quadratic function. And hopefully everybody remembers what a quadratic function looks like. Where we have the equation that y is equal to an ax squared plus bx plus c. So the fact that it has a degree 2 or an exponent of 2 tells us that this is going to be a parabola and or a quadratic function. So let's look at this question below. It says a farmer is building a fence to enclose a rectangular area against an existing wall, shown in the figure below. So that's really nice that they kind of give us the picture here so that way we can visualize what's going on. So we have kind of like a rectangle, except we're not going to use one of the walls or one of the sides because there's a wall there. So a rectangle labeled fenced in region is adjacent to a rectangle representing a wall. 3 of the sides will require fencing and the 4th wall already exists. If the farmer has 164 feet of fencing, what is the largest area the farmer can enclose? So this is what it's kind of asking you to do. Well, it's telling you that it has 164 feet of fencing. So whenever we're thinking about a rectangle and we're talking about fencing, that should kind of tell you it's the perimeter. So let's think about this for just quite a second. So if I were just to have a regular rectangle where I have a width, or let's say width, length, width, and length, right? That would be a perimeter of a rectangular area. So then my perimeter here would equal to 2w, because there are 2 w's. Because perimeter, don't forget, is adding all the sides. So if I'm adding on the sides, I have my 2w. Likewise, I have l's and I have 2l's. So a regular perimeter, I would have p is equal to 2w plus 2l. But that's not what I have. Instead, what I have is 3 sides. So our perimeter is slightly going to change. So let's say we have my width and my width and my length and my length. Now this length that I have here against the wall, they're telling you that you don't need any fencing there because a wall is going to enclose it. So you can kind of think of taking away that length that we have. So now perimeter, remember, it's still adding up all your sides, so it would have 1L, a W plus a W. Or better yet, you would have a perimeter is equal to 2W plus L, since you're adding all those sides together. Okay. Now, the other thing that it's asking you to do, well, it's talking about area. So if I'm talking about a regular rectangle, the area is going to equal to my length. So its area is equal to length times your width. So you have your L and your W for your area. So I'm just going to write it over here. Area is equal to L times my W. Now, it gives you some pieces of information. It particularly says how much fencing that you have. So you have 164 feet of fencing. So this is your perimeter. So your perimeter, you really have 164 is equal to 2W plus L. So what you can do here is isolate for L. So I'm going to minus 2W minus 2W. So that way it can cancel. So you're left with 164 minus 2W is equal to my L. So that's your new length that you have, since you only have 1. Now you can plug it into your area. So here, your area is equal to your length times your width. So area, so let's call it A, is equal to your length. But your length, you're substituting that in, and you have your W. What you're substituting in that L for over here is everything that I have here. So that would be the 164 minus my 2W. So that area is going to equal to 164 minus 2W times W. So now you're like, okay, well, I can distribute that W inside my parentheses. So then that's going to give me 164W. And then W times a negative 2W, that'll give me a negative 2W squared. And of course, I can go ahead and just rewrite this as in standard form. So I'd have a negative 2W squared plus a 164W. So all I did from here to here is just rewrite. And I rewrite it in my standard form. So now that I have this in standard form, what I want to do is I want to recognize what type of problem I have. So for this type of equation, I can tell that this is a quadratic function. And the reason I know it's a quadratic function is because the degree, or the exponent, is equal to 2. So because that's equal to 2, I definitely know that I have a quadratic function. So that means that I also have a parabola. So a parabola can either be facing upwards or it can be facing downwards. So this would be a positive parabola. And then over here I would have my negative parabola because it looks like you're frowning almost in a way. And the happy positive parabola is smiling at you. So now that I know this is a negative parabola, so this is the one that I'm looking at, I want to find, since it says the largest area, well, that largest area is going to be the maximum. So largest area, you can think of that as being the maximum. So if you think about that as a maximum, well, here, the vertex would represent the maximum. So remember that my equation, I have that my area is equal to a negative 2W squared plus 164W. So to find the maximum of this, what I want to do is I want to plug it into my equation to find the vertex. So the vertex is going to be a special ordered pair that's going to be at the very top. So I have my H and my K value to represent the vertex. So I can find my H value by plugging it into negative B over 2A. And here I have A is equal to negative 2 and B equal to 164. So I'm going to have this equal to negative my B value 2 times my A value. So then here my B value is a 164 and my B value is a negative 2. So I have a negative 164 being divided by a negative 4. So a negative divided by a negative is going to give you a positive. So 164 divided by 4 will give you a 41. So now I have that my H value is equal to 41. So my vertex now, I have my H value as 41. That tells me that the area that I was working with, where it's negative 2W squared plus 164W, well, I'm going to plug in that my W is equal to 41. So plug in 41 is equal to my W. So I'm going to have that my area is equal to a -2 plus a 164. And what I'm plugging in for my W here will be a 41. So I'm going to have the area is equal to -2 times 41 squared plus 164 times 41, which is going to give me 3362. So 3,362 square feet. So remember, this all started with my question. It says, if the farmer has 164 feet of fencing, what is the largest area the farmer can enclose? So this is the largest area that farmer can enclose. Okay, so my answer here is 3,362.